Hey everybody, today we're going to learn how to graph radical functions. Specifically, we're going to talk about two cases. We're going to talk about the square root of x, and we're going to talk about the cube root of x. So let's get started. The way we're going to do this is we're going to look at the parent function of y equals square root of x. Then we're going to look at three other examples by transformations. When we get to this part, I'm going to talk about how this is similar to how we graphed quadratics several weeks ago. When we get there, pay attention to how it relates. Try to remember what you know about graphing quadratics. Then we're going to talk about the parent function of y equals cube root of x, and we're going to graph one other example by transformation. The reason we're only doing one example here is because the stuff that you learn up here should transfer. So hopefully I can show you one example and you'll kind of get the gist. But also I'm kind of testing the waters. So the next thing we're going to do is we're going to look at the parent function of y equals x. So first, the parent function of y equals x. Now I'm going to graph this one differently than I graph the others because I want you to understand what I'm doing with my numbers later. So I'm going to graph this one by actually plugging in values. So I'm going to create myself a little XY table. Now I'm plugging into y equals square root of x, and in fact, before I really get started with this, I'm actually going to pull up my calculator because I want to get an idea of what this looks like. I have no problem if you guys want to do this in class. It gives you basically an idea of what to expect, but then I still expect to see your evidence, so I'll cover that when I get there. So remember, we're graphing square root of x, so I'm going to hit y equals, then I'm going to hit second square root of x, and then I'm going to hit enter. Now I'm going to graph that. If your graph looks funny on your calculator, hit zoom 6 and it should snap back to the middle here. So when I graph this, or when I complete my XY table, this helps me get an idea of what I should plug in. Notice it does not exist over here on the left side of the y-axis. I'll remind you that on the left side of the y-axis, x is negative. And since we're taking a square root, hopefully it makes sense that it doesn't exist over here because we can't take the square root of a negative number. You end up in the complex plane, so that's why the graph doesn't extend past the y-axis on the left. So I'm not going to plug in any negatives because they're not going to make sense. So this is what I better get when I graph it. So let's go back to the presentation. I've got my little XY table built up. So the first thing I'm going to try to plug in is I'm going to plug in 0. Well, this is the square root of 0, which is 0. So that's a good point to have. I'm going to plug in 1. Square root of 1 is 1. That's another good point to have. Let's plug in 2. If I take the square root of 2, 2 is not a perfect square, so I'm actually not going to plug this in. I'm going to forget about 2 because it doesn't work out evenly. So now that I've kind of realized that, I'm going to go to my next perfect square. Not 3, but I'm going to go to 4. And then the square root of 4 is 2. And I'm going to plug in one more number. My next perfect square, let's see, 5, 6, 7, 8, 9. My next perfect square would be 9, and its square root is 3. So notice that I'm jumping down my x-axis because I want my y values to turn out to be nice, pretty whole numbers. So this is something that's actually a good thing to do. So now I'll plot my dots. I've got 0, 0. I've got 1, 1. 1, 2, 3, 4, 2. And 5, 6, 7, 8, 9. 9, 1, 2, 3. So here's my graph. And I'm not very good, but you get the idea. Okay, so you don't have to label your points on your graph so long as you give me a table, or you don't have to give me a table so long as you label the points on your graph. So either way you want to show your evidence is fine with me, but I do need to see that evidence, because otherwise you threw it in a calculator and you just drew the picture. We've got to be better than the calculator. So either show me a table or label the points. I'll let you actually choose how you want to display your evidence. So that's how you graph y equals the square root of x. If it's the square root of x, these numbers will never change. So since this is the parent function, I'm actually going to keep this in mind for later. So next, I would like to look at 3 other examples that I'm going to graph by transformation. So I've got y equals square root of x minus 2. Now, if you remember way back from quadratics, we had y equals a times x minus h squared plus k. So I'm going to put a, h, and k in my general form here for radicals. So y equals a times the square root of x minus h plus k. Now, to remind you of what each one of these does, a will make it grow faster or grow slower. H will move it left and right. And remember, this is opposite of what I think it is. And K will make it go up or down. And this is, I keep this the same. The way we remembered that was opposite, keep. Opposite, keep. Okay? So hopefully you kind of remember that. Definitely by the time I'm done with this example, you should remember it, hopefully. So in this example, A is 1, so this does not get any bigger or any smaller than I would expect it to. There is no h, there's no number under the radical here with x, so this does not move left or right. But there is this minus 2 out here, so this does move down. So originally, I had, now notice I'm saying originally, I'm actually graphing my first example. I'm graphing the parent function here. So in my last example, 1, 2, 3, 4, 2, and 5, 6, 7, 8, 9, 3. Okay, so this is the parent function. All I'm going to do is I'm going to move this one down 2. So every one of these numbers is going to come down 2. 1, 2, 1, 2, 1, 2, and 1, 2. So this is y equals the square root of x minus 2. Actually did a pretty good job with that. So notice that all the points just came down 2. That's the only difference. That's why we graph by transformation. Notice I didn't have to throw out my calculator. Notice I didn't have to plug in any numbers. Because I had the original function memorized, it was actually very easy to graph. So that's the whole reason you would want to memorize the parent function. Alright, so that's the second example. So now, let's look at the next example. So this one has y equals square root of x plus 4. Notice that a is 1, so this isn't going to grow any faster or slower. H is actually negative 4, so this is actually going to go left 4 spaces. Remember, it's opposite and then keep out here, so this is the opposite of what I think. So plus 4 would typically mean right 4 spaces, but I do the opposite, so I'll go left 4 spaces. And I don't have any k values, so this doesn't go up or down at all. So again, I'm going to start with my parent function. Just ignore that red spot. I graph 0, 0. I graph 1, 1. I graph 4, 2. And I graph 9, 3. So that's my parent function. All of these are going to move left 4 spaces. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And 1, 2, 3, 4. So now I connect these new dots. And there you go. That is y equals the square root of x plus 4. So now we're going to graph y equals -1/2 square root of x minus 3 plus 1. When you have an a value, like we do here of -1/2, you need to do this in a kind of a specific order. So the first thing we're going to do is we're going to think about all of our coordinates from our parent function. Typically that would be 0, 0, 1, 1, 4, 2, and 9, 3. Okay, so there's the parent function. Now, since this has multiple steps, I'm going to switch colors. The first thing I need to do is I need to multiply all these by a half, all the y coordinates. So this has a y coordinate of 0. 0 times -1/2 is 0, so that stays there. This has a y coordinate of 1. 1 times -1/2 is -1/2, so this goes here. This has a y coordinate of 2. 2 times -1/2 is -1. And this has a y coordinate of 3. 3 times -1/2 is -3/2, which is 1.5. So I'll go down 1.5. So at this point, all I have done is I have applied the -1/2. I haven't applied the -3 or the +1. So let me do that real quick. Now that I have this basically graph, now all I have to do is move these green dots right 3 spaces, up 1. So this one's going to go right 3 spaces, 1, 2, 3, up 1. This one's going to go right 3 spaces, 1, 2, 3, up 1. This one's going to go right 3 spaces, 1, 2, 3, up 1. And this one's going to go right 3 spaces, 1, 2, 3, up 1. So my actual graph, after applying the -1/2 and the -3 plus 1, is this blue graph right here. Okay, so I think this is going to be the least obvious of all. So let me go back over what I did. The first thing I did was I graphed my parent function. I graphed that in red, which was 0, 0, 1, 1, 4, 2, and 9, 3. So the red dots was my parent function. I converted my parent function into the green dots by applying the -1/2. I multiplied that by the y coordinates. Okay, so that's how I got my green dots. Then I took my green dots, I moved them all right 3 spaces and up 1. And that's how I got my blue dots. And my blue dots were my graph. So you may want to rewind a little bit, replay what I just said, so maybe you can write down the steps. But that's how you graph square roots. So you saw how to move them up and down, you saw how to move them left and right, and you saw how to also manipulate them with an a value. So that takes care of square roots. Now we'll move on to cube roots. Again, we're going to look at the parent function, and then we're going to look how to basically graph one that has everything, an a value, an h, and a k, and you'll kind of hopefully get the idea because of what we just did. So first, let's look at the parent function. I am going to graph this one again by using an xy table. So let me get my color up here of red. So I have my xy table. Now I'm going to pull up my calculator because I want to get an idea of what this is going to look like. So go to y equals. I had this problem earlier for some reason, so I'm going to quit. Minimize this. Open up my calculator again. Alright, so I want to graph y equals the cube root. There should be a cube root shortcut on here somewhere. I believe it's under math, maybe. Yes, there it is. Number 4, option 4, so I hit 4. So y equals the cube root of x. To get there, I hit math, and then I hit option 4. So I'm going to graph y equals the cube root of x, get an idea of what that looks like. So go to graph. Oh, I can see this looks a lot more interesting. Notice it does go past my y-axis both directions, and that's because it's an odd root. If you remember from last week, the lesson where we had to throw in absolute values, we didn't have to throw them in when the exponent was odd or the root was odd, and we don't have to worry about negatives when the root is odd here, because an odd root can actually have negative values. So that's why it's on both sides. So I'm trying to make connections with what we've been doing so you kind of see how stuff links up. So this is on both sides. So I just need to get myself some values. What is really nice about this is kind of reflexive. Not perfectly reflexive, but you'll see what I do in a second. So let's go back to my presentation. All right. So like I did with the square roots, I'm going to try to pick perfect cubes. Since this goes both directions, I'm going to put 0 in the middle, and I'm going to get a couple values on either side. So if I plug in 0 to a cube root, the cube root of 0 is 0. I'm going to go -1 here, and then I'm going to go +1 here, because those are both perfect cubes. This is -1, and this is +1. Notice that these line up, except one is negative and one is positive. My next perfect cube is going to be 8. So I'll do -8 and +8. The cube root of 8 is 2. So this is going to get me -2 and +2. So notice how these almost look identical. Like I said, it was kind of reflexive, except these are negative. So I'm going to graph these points, 0, 0, 1, 1, and then 8, 2. And this is going to get me -1, -1, and that'd be 10, 9, 8, -2. So it does something to this effect. Okay, make sure you put your arrows on both ends. Make sure you take up your whole graph. So there's the cube root parent function. Now what you're going to watch me do is you're going to watch me move it up, down, left, right, and multiply by a. So it's the same idea. I'm going to be using these same points, except I'm going to basically have to do what I did in the last example. So here we go. The first thing I'm going to do is I'm going to take my y values of my parent function. I'm going to double them. Then I'm going to take that graph and move it left 1 space, down 4. So that's why I'm only doing one example, because I'm hoping that the first 3 examples went well enough that this just kind of makes more sense. So let me get my values down. 0, 0, 1, 1, -1, -1, and then 8, 2, and then -8, -2. Okay, so there's my parent function. Now I have to double all the y values. So I'm going to switch colors, and then I'm going to double all of these y values. This is going to go to -4. This is going to go to -2. This is going to stay at 0. This is going to go up to 2. And this is going to go up to 4. So all I have done at this point is I have applied this 2 right here by doubling my y values. Now all of these green dots have to be moved left 1 space, down 4, which is going to turn them into blue dots for me. So left 1 space, down 4. 1, 2, 3, 4. Left 1 space, down 4. 1, 2, 3, 4. Left 1, down 4. 1, 2, 3, 4. Left 1, down 4. 1, 2, 3, 4. And left 1, down 4. 1, 2, 3, 4. Should have my good graph now. Notice it matches up with the green dots, except it's just been moved left 1, down 4. So this is going to look like this. And that is how you graph a cube root function. You may not have to do all of this, but if you have an a value, apply it first, then move left, right, up, and down. If a is 1, forget about changing your y values, just move it up, down, left, or right, but always manipulate your parent function. So make sure you get those memorized. It's going to help you in the long run. So to recap, what we've done today is we have graphed radical functions. We looked at the parent function of a square root. Make sure you memorize those values, and then we looked how to transform it into other graphs. Then we looked at the parent function of a cube function, of a cube root, and then we looked how to graph one other example. So I think that's pretty cool. Hopefully this made sense to you guys. And then you basically have a few to graph yourself. Today's going to go a little bit different, so make sure you pay attention to the directions. But that is the end of the instructional part.